quick video to go over the journey of sound as it travels through all the equipment that you'll be using. So sound starts here with a source. In this situation, it's a human voice. The source of the vibrations is in the vocal cords, which are located in your throat. These compress the air, and then sound travels out of your mouth at the speed of sound. The speed of sound is 343 meters per second. Sound travels out of your mouth into the environment that you're in. In this situation, there's a microphone in front of it. A microphone is a transducer. It converts one type of energy into another type of energy, and in this situation, it converts sound pressure into an audio signal or an electrical signal. So as the sound pressure hits the diaphragm of the microphone, it moves forwards and backwards in a magnetic field, creating this audio signal. This audio signal is analog. What that means is it's smooth. There are no steps in it. Now the signal travels using an XLR cable when we're using a microphone, and it travels into the input of the Scarlett interface. This is the audio unit that we use at college. It's called a Focusrit Scarlett. All it does is it handles the audio signal from a microphone and it converts it into binary. So the signal comes in as analog, and then it is sampled many times a second. And what that means is it's measured many times a second to provide these values of where the wave was. This is because computers can't store analog information, but they can store digital information. So the audio interface here, if we follow the red line, converts the analog signal into a digital signal, and the signal comes out using the USB and it goes into the Mac, where it can be used and stored inside Logic Pro X or any DAW. If we have a look inside the audio signal in Logic, we can see that it's stepped because it's a digital signal, unlike the analog signal that we had earlier on. The signal is sampled 44.1 kilohertz, which means 44,100 times per second. And so each one of these little steps is that proportion of a second. Once you have the digital signal on Logic, you can mix it, you can add effects to it. The signal then is in digital format and needs to go back to the Scarlett to be converted back to an analog signal so that you can hear it out of the headphones. When the signal comes back from the computer, it is converted from digital back to analog, where it travels to the headphones. Headphones are just like a microphone in the sense that they are transducers. They convert one type of energy into another type. So they receive an audio signal or electrical signal, and they convert that into air pressure by vibrating the speakers, and that's how we get sound back out. In conclusion, this journey starts off as sound. It is then converted into an analog signal, which then gets converted to a digital signal so it can be processed by a computer, and then to listen back to it, it needs to be processed back to an analog signal and then converted back to sound pressure waves so that we can hear it. We sample at 44,100 times per second because we need to sample at twice the rate of the frequency that we can hear. The highest frequency we can hear is 20,000 vibrations per second, so we sample higher than 40,000 so that we can convert that frequency through this process and still be able to hear it on the other side.